Hi and welcome back to a new video. Yeah, it's exactly this time again we have to talk about our infamous connector again. About 2 weeks ago, Patrick reached out to me on Discord because he was gaming with his RTX 4090, and while gaming, he experienced suddenly an odd smell of burnt plastic, and then he was already like, oh my god, hopefully not me. Then he took apart the system and he couldn't take out the plug of his 4090, the 12-volt high power plug. My first reaction was just to ask him to take pictures from every single angle and then just reach out to the GPU vendor to find a solution for this, because honestly, I just didn't want to make another video about this topic again. But unfortunately, it turned out that Inno3D just didn't want to help him. And that's the situation we are left with. We have the full set here because everything is kind of melted together on both sides. The connector melted on the GPU side, apparently, and apparently also melted on the PSU side, because Patrick simply wasn't able to remove the plug from both ends. So it's quite obvious that we have some damage on both sides, and we will have to investigate this further and hopefully find a solution for him. You need serious power for demanding workloads? Then check out Hetzner, one of Germany's largest internet service providers. With its own data centers, high-performance servers and storage solutions, Hetzner provides the digital foundation for projects of every size. They also have VPS options with dedicated vCPUs that are perfect for massive data processing, machine learning, gaming servers, websites and high workload applications for super low prices. With the code DEBAUER15, new customers can even save $15 or €15. Find out more in the link in the description below. My first reaction was also to narrow down or figure out if we were even looking at the same problem or if it's something completely different, something completely random. But a combination of the smell of burnt plastic and not being able to remove the plug from both sides seems kind of obvious. And we also had a similar case a couple of weeks ago where we were looking at my 5090 and then we also saw very high temperature on the GPU side and on the PSU side, and I think kind of makes sense if you leave it there for too long, then this can probably happen. And before we continue to analyze this, I want to remind you that this is only possible because of the design of RTX 40 and 50 cards, with the card not being able to tell what kind of load distribution we have across the individual pins. We have 6 pins or 6 wires that are carrying 12 volt, and the card simply has no way to tell how much current is flowing across which of the wires. So that's the only reason why this kind of failure mechanism probably even happens. I want to add a quick note at this point because I was just watching the video myself while editing and I realized that I have to make something a bit more clear. Because the current GPU design, the card has no clue of telling what kind of current distribution is going on over the pins. So it could be a very uneven current distribution and this could lead to a connector melting, but it's maybe not the only reason why a connector could melt. We simply at this point don't really know what factors come into play that eventually lead to a connector melting, but the fact or the way the GPUs are currently being built are definitely favoring this condition overall. But this doesn't necessarily mean that the current distribution overall is the only reason why a connector would melt. This is a result of having different resistances, for example for the cable and also for the contact resistance for the connector itself. And then you could, for example, have 4 pins or 4 wires with a rather high contact or wire resistance, which is causing it to carry less current. And then the remaining 2 wires and remaining 2 connections would carry just a lot more current. And the card has no idea of what is going on, which can cause higher temperatures. Patrick then told me that he didn't want to be the next crybaby on Reddit crying about melting connector and, using third-party cable and all of this. And that's why I just also asked him reach out to Inno3D directly, because originally this was an Inno3D iGel card before it was transformed into a water cooling card. Unfortunately, Inno3D seems to spread the same and wrong technical propaganda that Nvidia previously spread. As a reply to Patrick's request, they just said that it can't be the GPU, because it wasn't getting hot on the GPU side. Instead, it was getting hot on the cable side and also on the PSU side, so it can't be the GPU, right? And this is the same thing that I pointed out before, that the cable side and the GPU side, the connectors are made from different materials usually. Because the GPU side is a side that's soldered on a PCB, has different temperature requirements than the cable side, which is usually not being soldered in the connector, which means they most of the time use PA66, for example, that can just withstand a much lower temperature. And that's why necessarily the cable side always melts first. Patrick then again replied to Inno3D asking for help and also about the warranty. and he said that he was concerned about pulling the cable out because it was just sitting so firmly on the GPU and he was worried about damaging the card itself. Then again, Inno3D replied, stating again that it has to be the cable or the PSU that is responsible for this because the cable melted on both sides. I find this explanation or excuse rather difficult and technically absolutely impossible to prove. The simple fact is that this kind of failure mechanism is impossible to resolve on the cable side or on the PSU side. It can only be solved on the GPU side. You will have different kind of resistances for the cable, for the connection and everything, and all of this is leading to an imbalance of current between the wires, which then can cause this failure mechanism. But the only side that can prevent this and the only side that is responsible for this in the end is the GPU side. Because no matter what you do on the cable, no matter what you do on the PSU, you can never for 100% avoid this. The cable is again from ModDIY, but I don't want to put the blame on them. I want to make this clear. Especially because we're also talking about an RTX 4090, which is running a much lower power draw than a 5090. And his 4090 was even undervolted. The cable he selected is using AWG 16 wires, which should be sufficient for a 4090. And as cable style, Patrick selected ultra soft wires, which should be perfect also for bending. I also asked him why he picked this exact cable, and he was absolutely aware of everything that was going on with the connectors melting at the time. And that's why he wanted to get a high quality cable, which is also ultra soft. As you can see, it's like extremely easy to bend. Same thing as Nvidia is doing now on the RTX 5090 adapters, because with this, you put just a lot less force on the connector when you're bending something. But also because he had only little space in his system, he wanted to have a cable that already has like a pre-bent 90-degree thing on here. According to the ModDIY website, they also used the newer 12-volt 2x6 H++ connector, which is still a quite questionable statement, because if we compare this with what Corsair is saying, they're saying that the change was purely done on the GPU side, but not on the cable side. And Corsair also stated that they only added the H++ marking on the cable side to not confuse users, or just to give them more safety. He then also reached out to ModDIY and their response was much better. They first asked if there were recent changes to his PC that might have caused this, but at the same time they also explained that this kind of issue can have multiple reasons and multiple components being involved, such as the GPU and also the PSU. ModDIY then recommended to reach out to the GPU vendor for an RMA, and they said that the GPU vendor should actually honor this. But well, we know that this didn't happen. At the end though, ModDIY offered to cover the costs of a possible repair if the GPU vendor doesn't do anything. So it's the classic Spider-Man meme of all the vendors blaming themselves and not really helping the one who is affected. Currently we're still waiting for a response from the PSU vendor, which is Silverstone, and if there's anything I will add it into at this part of the video. Before we do anything, we want to inspect the card in all detail and also the connector. I did this before I started shooting the video and I couldn't find anything. If we look at the cables here, but this is also the ground side of things, I cannot spot anything unusual. If we're looking at the connector itself and how it's plugged, everything looks absolutely fine to me. Cannot spot anything. Definitely not a user error of not plugging the connector correctly. I also love the burn-in pass sticker. Yeah, well, that's definitely what happened. You could theoretically do the same mistake on the PSU side because it's a native 12-volt high-power connector, but also here it's fully plugged. I cannot see any small gap on left and right. Looks fully plugged to me, no user error for sure. And also again, on the cable itself, it looks all absolutely normal to me. The PSU that was used is the Silverstone Extreme 850R 850-watt PSU, which should be sufficient for a 4090, especially because the 4090 was constantly running undervolted, so consuming less power. I think PSU selection was not the problem. I never pulled on any of the connectors so far because I wanted to do it on the video, and I will now try it and just get a first impression of this. Maybe I can just pull it out. Okay. Well, yeah, it's definitely sitting much stronger than usually. To be honest, I first wasn't sure, if it's a different person and you never know How experienced are they in building PCs? But I can confirm it's either super glued or I don't know. I can't get it out. I just started inspecting the connector a little bit in more detail, and then I noticed underneath this 12-volt cable right here, you can see a bit of molten plastic. This is definitely not normal and kind of confirms the issue that we're having. We will simply see if we can pull out the GPU side. Oh, okay. There are a lot of theories how this might happen, and one is, for example, also the contact resistance inside the connector. But if it would just be the contact resistance in the connector or the GPU side, then it would be very unlikely that you would have also the same failure on the PSU side. So it can only be a very uneven current distribution within the wires, which can only be caused by, for example, two wires having a very low resistance and also very low contact resistance, and then, for example, four wires having a very high contact resistance. It's basically the only way how this would work. Otherwise, we would only see the failure on one of the sides, like either on the PSU side or on the GPU side, if it would solely be a problem of the contact resistance of the pins, but that's not the case. I think I will just try with brutal force and see if we can at least unplug it from here. Interesting, because it was not one of the center pins, but it was the outside 12-volt pin that partially broke off, but you can also see discoloring on the pin itself right here. And here the opposite side, bottom left, which is this 12-volt pin I was just talking about, you can see some of the remaining plastic still inside that broke off. On the PSU side, it should be this one where I couldn't spot anything, but I could spot it on here, which is actually odd. Oh, well, I somehow disassembled the connector out of the PSU, but this is still sitting firmly together. At least on the PSU side, we can also see that this pin is a bit darker, the same one that we found looking strange before. At least we finally achieved what we wanted. We could get the cable out, which means I can take the card apart and then we can remove the old connector and just replace it with a new one, basically doing the GPU vendor's work. The card is now fully disassembled. I inspected everything, and at least for the thermal part, for thermal pads and TIM and everything, no issues at all. Everything was correctly assembled. Also inspected the connector from the back, but I couldn't find anything unusual there. I also want to highlight that I'm absolutely not an expert when it comes to doing solder work like this. I did it a couple of times, so I know what kind of pain it is to replace the 12-volt high power connector. It has a lot of pins and there is quite some copper in the PCB in that area, which means that you have to preheat the PCB, but even then I was never able to fully melt all of those pins and then just get it out in one piece. Mostly, or actually every time when I did it, I had to destroy the connector in order to get it out. So I had to cut some of the pins and then take out the pins individually. The majority of the connector is already removed and the card is now sitting on a heating plate. And we're waiting now for the card to get some temperature, because otherwise, as I said, there's just too much copper and stuff and you wouldn't be able to heat it up to take the pins out. And with this, the original connector was removed. Holes and everything are clean, so we can proceed adding the new one. And the new connector is also going to be H++. The new connector is in place. I also already measured the resistance between 12 volt and ground just to make sure that there is no bridge or short or anything. But this all looked good. Now I only have to clean everything, apply fresh thermal paste, and then we should be good to go. I'm just testing the card to make sure that everything is running fine, and while talking to Patrick before shooting the video, he also pointed out that he had sometimes weird performance issues, or at least his 3D Mark score was lower than expected, and I maybe found something. The card is only running with X8 4.0 PCIe lanes, and I obviously also tried to fix this by taking the card back and out and also different slots and everything, but it wouldn't change. And with a different GPU, I always have X16, so it has to be this specific card. It shouldn't be a great performance loss. It's something you can definitely notice in a 3D Mark, but for gaming, I think this should still be okay if it only runs at half the PCIe lanes. I ran Speedway for 20 minutes. Everything looks great. Temperatures with Duronaut as thermal paste, not bad at all. We see about 45 on the GPU, 55 hotspot memory at 60. That all looks great. Board power draw 430. No issues from my side that I could find, and if he had any kind of performance issues, I would suspect that it comes from the card only running X8. And now it's getting interesting again, because in this case I saw an opportunity to investigate the entire melting connector thing a little bit further. Because for me it was the first time that I had a case where the connector was still plugged. And then I thought, okay, so this might be a chance to actually measure what kind of internal resistance or what kind of connector mating resistance we can get from the cable to the graphics card. And for this I have a milliohm meter. This milliohm meter is quite accurate and can measure very tiny resistances. And with this I performed measurements from the center of the cable to the back side of the PCB to the pins of the 12-volt high power connector. And in this case, for example, measuring pin 1, I measured a resistance of 43 milliohms. The measured resistance will be partially the cable itself and then the connector or the mating resistance inside the connector itself. At this point I also had no idea how many pins are affected or if there are even pins affected. The only thing I could directly find out was that there was a bigger fluctuation between the pins in terms of contact resistance, and that on pin 6 I just couldn't measure any resistance at all, which means that there was no connection, which was weird. But I also want to highlight that measuring this now is only helpful to a certain degree, because it's obviously not the situation prior to when the connector melted. So we definitely changed something. That's firstly, if a pin melts, then you have a physical change inside the connector itself. So the pin inside can move once the plastic is a little bit more soft or liquid. So that is the first change. And then obviously also Patrick told me that he tried to pull out the connector from the graphics card, which will introduce movement and then also a change to the connector and probably also to the contact resistances. So it's only helpful to a very limited degree, but yeah, just try what we can get from this, right? Now in this overview you see what I'm talking about with a quite big range of contact resistances. We see 43 milliohms at pin 1, 19 at pin 2, 12 at pin 3, 14 at pin 4 and 39 at pin 5. As I said before, pin 6 I just didn't have a connection, so I put not connected. Pin 3 is in particular interesting with the 12.1 milliohms because this is at the same time the lowest resistance and also the pin of the wire that was damaged on the PSU side. What also comes into play is the contact resistance of the crimping. So the small contact in front is only crimped to the wire. So it's just squeezed to it, it's not soldered to it. And there's also a small contact resistance that happens by doing this. And here I took out a small wire from this Corsair 12-volt high power cable. It's exactly 10 centimeters long. And now we will measure the resistance from the start of the wire to the front. And this should give us the total contact resistance or the total resistance of the wire plus the contact resistance of the small pin in front. And in this case, we measure 1.7 milliohms for the tiny wire with the contact in front. So that gives us the resistance of the pin, of the wire, and the contact resistance, all three together, only 1.7 milliohms. But with those resistances, we can at least in theory calculate some values of the current distribution across the cable, because the resistance will determine how the current that is flowing to the card is shared across the 6 12-volt lanes or 12-volt wires. I'm just reusing this draft which was sent to me for simulations by a viewer, which is extremely helpful. I just adjusted it with my values. So on the right side we have the PSU and on the left side we have the GPU. There we see 12 volt and 38 amps, which equals 450 watts, and that should be what an RTX 5090 is doing max under load. On top you can see the different resistances that I measured with pin 1 to pin 5 according to the table that I just showed you. Pin 6 currently not connected in this case because I couldn't measure a resistance, but this is obviously not the situation when the connector burned because we know there had to be a current flowing, otherwise it wouldn't have burned. And then on the right side you can see the currents, and that can be as low as 5.2 amps on pin 1, which is determined by the 43 milliohms. And then you can also see as high as 10 amps on pin 3, and this is the one that was melting on the PSU side. Again, the current here was not correct because we were missing the pin 6, which would also carry something, I don't know, like 5 to 8 amps or something like that. But as I said, I couldn't measure resistance, so we probably have to work with an assumption here. I thought of looking at two different cases. One would be with a rather high resistance of 25 milliohms. In this case, the wire would have carried 6 amps, which is at least for the wire still in the specification. If we go down as low as 12 milliohm, which we measured on the pin 3, then both pin 3 and pin 6 would both carry 6 amps. And now with this current and the resistances, we can calculate what kind of power draw and thus heat we are generating inside the connector. However, those resistances also are partially the cable. But I left it in there because the cable will also get warm to a certain degree and can help heating up the connector itself. That is a case we observed in the past when there was a very uneven current distribution and we had a very high current flowing across one or two wires. It is heating up everything, and also with the connector. And now with the formula P equals I squared R, we can calculate it, and with pin 3 and pin 8, we would have a power consumption or a heat that is generated of roughly 0.8 watts. Now we can do the same thing for the other pins as well, because we have the current and also the resistances, and we see actually a very even heat distribution or heat generation of about 0.7 to 0.8 watts per pin or also per wire, which is giving us a total heat generated, in this case of about 4.6 watts. That is not only for the connector, but also for part of the cable itself. In the first moment, all of this doesn't sound too concerning, but it kinda is. Because if we think of having 4.6 watts, that is not an enormous amount of heat, but for a connector it can be. But for me personally, what is actually more concerning is the contact resistance. Because if you look at the specification by Molex, if you look at the mini-fit connector and what the contact resistance max should be, they state it should be max 10 milliohms, and typically it would be a lot lower. But as you know, we measured much higher contact resistances, or overall resistances at least. But we measured from the half portion of the cable to the connector itself, to the backside of the PCB. That means we also had a portion of the cable in there, at least when it comes to the resistance. So I thought, okay, I also have to figure out what kind of resistance we're looking at for the cable itself. I used the same original point of measurement in the center of the cable and then at the end at the connector, and for this length of the cable I was measuring a resistance of 6.4 ohms. If we now take those 6 milliohms and deduct it from our previously measured values, then we know that at least pin 1, 2 and 5 would be out of spec when it comes to the contact resistance. Now you might think, okay, then those should be the pins that burn. Seems not to be that easy, because if you have a very high resistance, it kind of equals to cutting the wire. If you think of like an unlimited high resistance, it's the same as cutting the wire, then the current is just distributed across the remaining wires. And we know with the formula that P equals I squared times R, that the current itself is squared into the equation, causes much more of a power draw or more of the heat that is being generated. So it's not simply as, it's contact resistance or it's current, it's probably a combination of both, that you have like high contact resistance on a couple of pins, which is causing high currents on some other pins, but that is just pure speculation. To be honest, I don't really know what is causing this or what caused this or what caused the pin to burn. That's just pure speculation. All that I could see in this case is in the state that it arrived, and when I measured the resistances, we have very uneven resistances causing definitely uneven current distribution, and we know that something went wrong here. If you overall have a higher contact resistance for the entire connector, it also means that you have more heat that is being generated. And with calculated 4.6 watts, that is already substantial for a connector. And then if you have the contact patch where the connectors are mating is a very tiny surface, and locally that can definitely generate quite some heat. Overall, this case is for me a perfect example that it seems like the vendors have not really investigated or found the issue of what was actually going on. I'm not sure if NVIDIA found this out by now or if they just didn't communicate it to their partners, but at least for Inno3D's case, it seems like what they replied didn't have any kind of technical substance to it, because looking at some images and then seeing that the wire is stuck to the PSU and the GPU and then coming to the conclusion that it can't be the GPU is technically just wrong. You won't be able to tell if it's the GPU, the cable or the PSU, but I personally would at least expect that if you paid 2,000 euro for a graphics card and you're still within warranty, that the vendor at least asks you to send it in, let me investigate it, and then maybe come to a conclusion. Obviously, maybe if they investigate it, if they have some engineers with more background on this, then they could come to a conclusion and tell, look, it was really the cable's fault. It is possible. But, it's, at least for me, it's impossible to tell which of the three components causes this or caused it in this case. And so it will be impossible for Inno3D to just judge from looking at, an email and some images. That was pretty disappointing. And I hope that the vendors would, take responsibility, because in the end, it's NVIDIA's mess. They caused this with their, lazy, I would say, power design, just making all of this possible and then taking no responsibility through their partners. That's just not nice, because in the end, the consumer is the one who has to pay for this, literally, like in this case. And I hope, sincerely, that NVIDIA fixes this for the upcoming generation, because to me, it feels like nobody really found the real cause of this. It certainly was not the length of the pins, as we know, because the problem still happens once in a while. All right, enough for this video. See you next time. Bye-bye.